everyone, it's Larson in the lab, and today I'm actually going to record two labs in the same video. So the first is going to be the heating curve of water, and that's going to be all my supplies that are right over here. So what I've got is I have a ring stand, and the ring stand is holding a temperature probe that is connected to my computer to a program that is actually going to record data from the temperature probe throughout the experiment. And what I'm doing then is I'm going to start by heating my water. I'm going to start with frozen water or the solid form ice. I do have to put that ice with a bit of water so that it will create an ice bath and that will begin to warm. But as I warm it, I'm going to be using this hot plate, and this hot plate has a stir function. So when I put this magnetic stir in the beaker, it will actually be able to be stirred by this magnetic hot plate, and that's going to be able to keep the temperature distributed evenly throughout this entire system, throughout the beaker, as we heat our water. So I'm going to put this magnetic stirrer in, and I'm going to add about 150 milliliters of water. Here, I might be adding a little bit more water soon. I'm going to start putting the ice in. So this is just ice from the freezer. And I'm going to go ahead and put that in. It just might take me a moment. I'm going to get a little bit more water. 150 more milliliters. Add to my beaker. All right, and now what I'm going to do is lower my temperature probe into the water. And I'm placing my temperature probe so it's right in the middle of the water. I'll save this ice and use it for another lab. Before we really get started, I'm going to go ahead. I'm going to turn this on, and then I'm going to come over to the computer and turn on the recording for this heat curve. So I'm turning it on to stir. That's the magnetic stir bar. So all that's happening right now is just the liquids being stirred. You can kind of see the motion there. And I'm going to go ahead and turn the heat on to about 350 degrees Celsius. And I'm going to come turn on my graph from my probe software. So I guess you'll just get to look at me while I do that. I am now collecting data. I'm starting at 1.3 degrees Celsius, so pretty much freezing, right around 0 degrees Celsius. So what we're going to do is we are going to be able to see what happens in our heat curve over time as this beaker begins to warm up. Okay, so the heat curve is kind of like set and forget. You just set it up, it's collecting data, and we are beginning the process of heating this beaker full of initially ice, and that's going to then, of course, receive the heat energy. The temperature will increase, and at some point in time, our ice will begin to melt into liquid. At that point in time, we're having a phase change, so we should not be increasing temperature. Then we will see later on, once the liquid it's all completely liquid, the ice is melted, we will start to see a temperature change again as the liquid is warmed. That will warm to a point of boiling, and that's going to be 100 degrees Celsius, and then vaporization will be taking place at that point in time. So I'm going to let that run while I show you our other lab for this week. And our other lab is a catalyst lab. So I'm going to be working with two substances here. I have hydrogen peroxide, which is what you could typically find in, like a CVS type of store. I also have magnesium dioxide, and hydrogen peroxide has the chemical formula H2O2, and magnesium oxide will actually serve as the catalyst to break down our hydrogen peroxide into oxygen and hydrogen. And so, or oxygen and water, sorry. So what we're going to have is we're going to have some oxygen that gets given off when hydrogen peroxide is broken down into its component parts. Again, magnesium dioxide is going to be the catalyst for that reaction to take place. So what we're going to be doing here is I'm going to have two test tubes, and I have them in a test tube stand. And in one of those test tubes, I'm going to fill it about half full of hydrogen peroxide. So I'm going to go ahead and do that. This lab is very qualitative. So if it were more quantitative, I would be measuring an exact amount of hydrogen peroxide that I'm using, but it is qualitative. I'm just saying it's about half full. All right, and then I'm going to put some magnesium dioxide into this test tube. And again, this is a very qualitative lab, not quantitative. And since it's qualitative, I'm just going to say I'm going to put about 2 scoops. If I was being more quantitative, I would use an electronic balance and actually measure a specific mass of magnesium dioxide, but I'm not doing that today. All right, so I now have about 2 scoops of magnesium dioxide in my other beaker. So what I'm going to be doing for this lab is I want to know how much hydrogen peroxide is being broken down and releasing oxygen, because it's going to be broken into water and oxygen. The oxygen is going to be able to be visualized in this lab through flame. So yes, in this lab, I have ice, I have fire. For this part of the lab, what I'm going to be doing is I'm going to be lighting this stick on fire, and I'm going to wait until it's glowing orange with an ember. I'm then going to blow out the flame. After that, I'm going to place that ember into the beaker or into the test tube where the hydrogen peroxide is, and I will see if it will reignite or light up again. If it reignites, that means there's enough oxygen to produce that flame. If it doesn't reignite, there is not a lot of oxygen. Then I'm going to blow that out. If I need to relight it to get a new ember, I will. I will then be putting it into the test tube where the magnesium dioxide is and seeing if that produces any oxygen or if it starts a flame. Okay, after I do those 2 steps to show what initially looks like, I'm going to combine these two by putting the hydrogen peroxide into the magnesium dioxide test tube, letting them combine, and then I will be ready to show this flame test again. So here we go. I want this to be lit for long enough and well enough that it has an orange ember. So it's got to have like that orange ember. Like if you were doing a bonfire, you would see that orange ember kind of at the bottom of the fire. So it's got to stay lit for a little bit in order to get that nice orange ember. I want plenty of that nice orange ember. So I'm going to let this go for a little bit. I'm then going to blow it out. See, I do have an orange ember there. I'm now putting that in my hydrogen peroxide test tube, and there is no flame. Okay, no flame happened. All right, I still have a little bit of a glowing orange ember, but I'm gonna get that started up again here using my Aim and Flame lighter. As you can see over to my left, our ice is starting to melt a little bit, and we're warming up to eventually have a phase change to liquid. Okay, I got an orange ember again, and I'm going to show that in my magnesium dioxide test tube. No flame there. Okay, no flame at all. All right, so next up, I do need to keep an orange ember, and I need to have that ember ready right when I combine these two. I need to have that orange ember ready when I put the hydrogen peroxide into the magnesium dioxide. So I'm gonna make sure here, actually, I'm going to use another stick just to make sure I have enough room to keep my hands safe. So I'm going to light this one. I'm going to get an orange ember, and then I'll combine my hydrogen peroxide with the catalyst, which is magnesium dioxide, and see what happens. Sometimes it takes a second for these sticks to get lit because they do have a little bit of a waxy coating. And these wood splints, they do a nice job for this lab to keep that ember. I'm gonna let this burn for just a moment, get that orange ember that looks nice. Then I'm gonna blow it out and combine my two liquids. I want that orange ember to be ready to go. Okay, you see the orange ember? I'm now going to combine my two liquids and watch what happens. It lights back up. And I can do it again. What is making that fire start back up? Well, it's the oxygen. It's a sign that the hydrogen peroxide is actually being broken down. And I can continue this until all of the hydrogen peroxide is completely broken up by decomposition reaction with magnesium dioxide as my catalyst. So until all of the hydrogen peroxide actually breaks down in decomposition, I will continue to be able to do this process of starting fire on my wood splint. Interestingly, I cannot run out of magnesium dioxide here because catalysts can be reused over and over and over and over. So if this stops lighting back up, that means that all the hydrogen peroxide has been broken down, but it means nothing about the amount of magnesium dioxide left, because that would mean that the magnesium dioxide is a catalyst that gets reused and not, destroyed during the process of the reaction. As you can see, I am no longer getting a flame when I stick this wood splint with the ember into the test tube, and that means that all of my hydrogen dioxide has been broken down effectively and decomposed by my catalyst, with the help of my catalyst, which lowered the activation energy and made that happen much more quickly than just the hydrogen peroxide sitting in a test tube by itself. All right, over here, you can start to see I do still have some ice remaining in my ice bath. So that means that the temperature is still increasing within that solid ice state. And once we reach having the phase change from solid to liquid, temperature will not be increasing for a while because you can only have either phase change or temperature increase. So if the phase change is occurring, we will not have a temperature increase on our graph. We will have to wait until it is all completely liquid to begin increasing the temperature of our system again. And then eventually we will see that occur again when the water begins to boil. I'm not going to keep the video on for as long as it would take for this ice bath experiment to continue, because it will take probably 30 to 45 minutes, and I don't think you want to watch a video for that long. But it will all be recorded by my probe, and I will share a screenshot of the graph that is produced by my data. Thanks so much for listening.